morning, everyone. My name is Maciej Łukiański, and I will be talking today about a continuous integration in a Drupal project. Before I begin, let me tell you a little bit about Droptica, the company I work in. We are probably the biggest company that does Drupal in Poland. We are a team of 35 developers located in 3 offices in Wrocław, that's here, in Gdańsk, in the north of Poland, and in Rzeszów. We are growing really fast. We work with clients in Poland and in Europe, also outside of Europe as well. We are a company that, from its origins, we are really close to the community. We sponsored probably every Drupal camp in Poland that ever happened. We sponsor camps outside of Poland, like DrupalCamp Poland, for example. Last year we sponsored that. We talk at conferences as well, both in Poland and in Europe. We are one of the companies that founded the Drupal Marketing Foundation Poland as well, and we're just 3 hours from London and Paris. We're hiring, that's another thing. Check out our careers website. We are looking for Drupal developers, PHP developers, and if you know Drupal really well, you don't really have to be located in any of these offices. You can work with us from wherever you are at the moment. So that's it about us, and let's move on to the presentation. So, continuous integration. Why this presentation in the first place? So, we are working with Drupal since almost 10 years now, and it seems to us that hardly anybody uses continuous integration in Drupal. We do. We use it on practically all the projects that we work on, and we love it. We think it's the only way to build a big, reliable project on Drupal. Without continuous integration, you have loads of risks, which we think you can mitigate by just using continuous integration. And today I'm going to try to show you how we do continuous integration, what continuous integration is, and try to persuade you a little bit that if you're not using continuous integration at the moment, you can try, and it's not that difficult. So let's start from the definition. I really have to press very hard here. So the presentation plan. What is continuous integration and how we use it in Drupal? I'm just going to use... Okay, so what is continuous integration? There is a definition, more or less, which I kind of adjusted a little bit. It's a development practice of merging all developer working copies into a shared main line often. For example, once a day. And then each merge is then verified by an automated build, allowing teams to detect problems early. And this is more or less a definition of continuous integration. I'm going to show you how it works in practice. Before we get to that, there are a few principles of continuous integration that I want to talk about. So there's 9 of them. They are all listed here, but I will just kind of go through them really quickly, and then I will explore each single one a little bit more as we move through the presentation. So there's a code repository. Everybody commits to the main branch often. I say often. Some people say once a day. Some people say every few hours. Like, depends. Every merge to the main branch is built. The build is automated. We're building and testing in a clone of production environment. The build is tested, and the build is fast. And then once you have all that, you can automate deployments, and and there's the last but not least, the last principle, it is easy to get the latest version of the software. So let's go through all these, right? So there's a code repository. Obviously, the reason for probably... Is there anyone who doesn't use Git or SVN or some sort of code repository? I think this is a de facto standard now, but this is the first principle. And the most important thing, which is often sometimes still neglected, that is that it is the single source of software. So you shouldn't have a code repository and then like 5 additional scripts that you're sharing via email for deployment or whatever. Everything should be kept in a code repository. And so the process of setting up a project shouldn't be like, okay, you do all these things and then only you download the code repository. You should really have everything in the code repository. And then all the changes are tracked. There are loads of tools. We usually use Bitbucket, obviously for the pricing reasons. GitHub we use quite a lot as well. And there's GitLab as well. Some of our clients use it, and we're working with them. We use GitLab as well. GitLab also gives you nice continuous integration features, which kind of are out of the box. Now Drupal is moved to GitLab as well, which is an interesting thing. Okay, everybody commits to the main branch often. Now, I have a rule of thumb here. If you don't commit to the main branch often, you get merge conflicts and loads of issues. Now, in Droptica, we recommend that you should commit very often, at least at the end of the day, so that if you go home and everybody has all the code that you worked on, even if you, but there's a rule of thumb, like if you have 1 or 2 developers on a project, you maybe can even merge with each feature. So one person can work a week on a feature and the other can work on a feature, and then you can merge it. And you two communicating together can resolve conflicts if there are any quite easily, or you can kind of discuss, or like, I'm working on this, I'm gonna, edit these files or whatever. It works. It's probably not a great thing, but it works. If you have 3 to 4 developers, you should at least commit every second day. And if you have a team of over 5, you should really be committing every day. Like if you're not committing every day, you'll spend a lot of time resolving merge conflicts and all sorts of issues that will just take a lot of your time. So, and then often people will work on the same things, edit same CSS files, and it's gonna get messy. So the more often you commit, the better. But there are caveats to it, of course. You should commit code that works. You shouldn't commit a code with some comments on it that doesn't really work. What should go, if you're pushing code into the main branch, so if you're creating a pull request, this should be a code that actually works. If you're committing to your own feature branch, you may be committing code that doesn't work. That's fine. For example, if you're leaving for the day, but you haven't finished yet and you're going to continue tomorrow, you can commit into your feature branch, just like not to have it all the work on your machine, but to kind of share it with the team. But once you're merging it to the main branch, the code should work. So it shouldn't be some gibberish. It shouldn't be some, like, it should actually be reviewable by a peer or a superior, a senior developer should be able to review. Exactly. It should pass. It should be passing code review, and it shouldn't break the build. If you're committing code that doesn't work or is not yet really finished, it often happens that you come in on the next day and like there's an emergency or something, and you're supposed to work on something else, and then this kind of not finished code just kind of stays there forever. So we advise to commit code that works, so that you don't end up with a project with like 3 modules added that were supposed to be enabled, but then we changed our mind. We only commit code that works and actually makes sense and we want it in the project. We use Git Flow. Probably most of you know Git Flow. It's a mechanism of, I'm not going to delve into much detail here, but we use Git Flow for managing code. Like, it's going to be a bit important later in the process, but we have the main master branch, which is the production branch, and you can see the releases like V1, V2, V1.0. We have a hotfix branch usually for really quick fixes to production if there are any errors. We have a develop branch, the purple one, which is the main. This is the main branch. If I'm talking about the main branch that everybody should kind of merge to, this is the purple one. And then we have feature branches, which are the green ones, that when you work, you can work on them, and then you should merge them into the main branch as often as possible. Okay, so the principle number 3 and 4, there is a build and it is automated. So it says that each commit automatically creates a version with the latest code. And in Drupal, in our opinion, what it means, it means that there's an automated way to create a version of the website which you would obtain if you committed the main branch to production. So not to like so. So basically, the build is an automatic creation of a version of the website to which you would commit code, like of a production website to which you commit the new code. And this is fairly important. Like I even marked it in red here that if we deployed code to production, so it's like many times in Drupal, and it happens that people have a staging environment which is different than production, which is different than dev, and committing code to staging or development doesn't really give you the exact same thing as production. That I think this is an error. You should, right? And you should build in a clone of production. That's another thing, often neglected. So the closer the better. And in Drupal, you should have a recent copy of a production database. That's, in my opinion, like important. So oftentimes people have a development database, a staging database, and a production database, and they are completely different. They have completely different content, completely different sometimes with modules enabled, because like once as development happens, they kind of go out of sync, and they are not synced often enough, and often you have these situations, oh, it worked on dev, it doesn't work on production, oh, because there are differences. Well, that shouldn't be the case. The way we try to organize processes every time, we try to organize it so that if it worked on dev, it's going to work on production because they are identical. That's how we try to do it. I'm going to show you how we try to organize it so that it happens. So a build in Drupal, I'm going to talk a little bit about what we understand by a build in Drupal. A build in Drupal is deploying code to a copy of the database from production. So in a nutshell, if you were to kind of do a build locally, you'd import the database, you'd deploy the latest code, maybe, run composer install, and you would apply all changes. So import configuration, turn on or off modules, run updates, clear caches. Usually the way we do it, we turn on modules on and off in the updates, so that all the changes that are applied to the website are done through code. And a build can just be really a bash script, like all these steps that I kind of described earlier. You can just create a short, simple script that will just do it for you, like you have Drush, and it should work. And so this is really it. Like for a long time, this is the simplistic version of the build that we used to use, and often if say your automatic build broke, you could really do that, and that would really be like a manual mechanism for an automated build. Right. So we're pulling the latest code, importing the database copy of a production database, or like a database close to production, and we run updates, and that should change like whatever we want to deploy. That should be able, like it should be deployable through an update, and then we clear caches, and that's. Nowadays we use a little bit more automated process. We use Ansible, and you can see that in the red we install Composer. Like we have all these roles and steps defined in Ansible, and then it's a one command with Ansible playbook build, and it does the same. It installs Composer, imports MySQL, imports all configs, runs appdb, clears caches. And depending on the website, you can kind of change these steps. Like you can remove import config, you might do something else. Like you can actually run a shell script. Like here it's just a shell. It's just a shell script. Crash clear cache rebuild. Okay. So this is it. We use Ansible to have environments really close to production. We use Docker. A simple Docker compose file like the one here already gives you a full environment that is really required to run Drupal. So it's an Apache with PHP 7 and a MySQL, and really you can just start up Drupal on the like if you install Docker Compose on your machine, insert these lines. You can launch an environment which will be a working version in which you can run Drupal, and you can see that there's an image called the Droptica Apache PHP 7.0. All the images that we use are open source, so you can go in and use them. You can see them on GitHub, their composition, and they're open and available. We keep them up to date automatically as well, so that if there are any security patches to any libraries, these are getting updated. So, of course, in a real production environment, there's more to the Docker Compose or to the real development. I'm going to show you a little bit here, a little bit more here. Like our Docker Compose files are usually a little bit more complex. Sorry. But this is enough to just start up. And Docker is really great. Who has used Docker already? Brilliant, right? So you almost all of you know that it's really easy to replicate environments. It's really you keep the Docker Compose in your Git repository, and then you have the environment bundled up with your software, and you have like a complete app. And then if you change anything in your environment, you add a library, you change a library, change a PHP version or whatever, it quickly propagates to all the developers, all the environments. So you don't have a situation like, some people have where, oh yeah, we have PHP 7 on development, but production still runs 5.6 because we can't really upgrade it. This is not a good way to do this integration. So yeah, this is how we do it, and you can see now when you have the MySQL container and Apache PHP, we don't really add Drush or any scripts into those. These are just they just have these things that are required to run Drupal, and we just attach another PHP dev image which has Ansible and Drush and whatnot in there, and it just attaches to the two for the moment of the build, and then we can detach it, and it will actually run Ansible for us and do all these steps. Like it will import, install Composer, it will update the database and all, and do all these commands that we want. A little bit, okay. So this is so we have a build and it is automated. Like we use Docker and Ansible. You can use a Bash script. You can use whatever. It doesn't really matter as long as it's a one script which is automatic and you don't have to do any manual steps in there. Another principle: the build is tested. Now there are all sorts of tests that you can do. You can do manual tests. You can do unit, functional, visual regression tests. I have these icons here, which we will be using a little bit farther down the line in the presentation. I'm not going to talk too much about manual tests. These are obvious, right? You have acceptance criteria or whatever, and quality assurance personnel just kind of makes sure that what was developed is actually what you want to achieve. We do a lot of automated tests. Mostly these are functional tests and visual regression tests. I'm going to talk a little bit about these types of tests here, starting from functional tests. In Droptica, we use Codeception. We try to test all projects. Of course, it depends on budgets and all sorts of things. but it's a really good way. Testing is a really good way to make sure that when you have a long life cycle of a project, that things don't break, that things actually work as expected. If I were to say, it's good to test at least the important pieces of your software. So, say if you have a commerce website, it should be able to, like, people should be able to buy stuff. So you should make sure that your process of adding to cart and checking out works. If you have a lead generation website, your forms should work. And you should really check it every time with each deployment so that you're absolutely sure that you didn't release, say, on Friday or Thursday something that doesn't work, and then on Monday you're coming in saying that there are no orders because people couldn't order. The more you test, the better, but it makes sense to keep, a sane approach to that. So we use Codeception. This is how our outputs of our tests look like. Like you can see here that we are checking that the blog section response code is 200, that you can switch to you can walk through a pager, that you can go to a particular section, or you can open a Drupal 8 REST JSON integration, simple JavaScript application, blog post, and that it all works. So this test kind of sanity checks that the blog works. So with each deployment, and these are 4 tests. For example, for our Droptica.com website, we have all these tests here, which check all the functionalities of the website. So whenever we change stuff, whenever we update, version, like Drupal version or module versions, we just run these tests. We don't have to click around to make sure that everything works. We know that everything works because tests tell us, right, that everything works. And whenever we build a feature, Jenkins automatically builds for us the website and runs these tests. We see, okay, nothing's broken. And we do visual regression tests as well. Now, this is functional tests are really cool. They check all the functionality, but they can't tell you if your paddings are out of line or somebody styling something broke something else. For this, we use visual regression. I'm saying here we compare against production. That's often the case, true. But we can compare it, to anything, to a previous version or whatever. And it's a pixel by pixel compare. It runs a bit long, but it gives us a good indication of things that broke. We usually run it once every night, more or less. And it's a simple Jenkins setup where we can just input the URL that we want to compare, and we can kind of ignore stuff like, a GDPR pop-up or something, and we can just inspect pages, and we can see this is the output of these tests. We can see that, there are some blog pages compared, and this is how an error looks like. Like you have the production image, you have the new version, and you can see that, grid changed or something, and something looks different. It will show you that. And it might be expected. That might be a feature that you wanted to introduce, that on this particular mobile version, you wanted to change stuff, but it might not. So we will, when we started using that, we removed all these problems like changing font sizes, changing paddings. These are things that happen on a project that's maintained for a long time and has all CSS, a lot of CSS created. Visual regressions catch quickly that, on one of the websites button a bit smaller or larger, these errors sometimes happen. Well, we mitigate those errors. We don't send production websites where on some page down in the menu something changed that we don't know about. We can catch it. The build is fast. That's the principle 7. In Drupal, builds are fairly fast in general. I mean, the build is fast. It means that it doesn't take 2 days or a day or 5 hours. It's fast enough so that you can actually test that what you did makes sense, and it's a reasonable time frame in which you can test. In Drupal, importing large databases is problematic. Like if we have clients who have hundreds of gigabytes of data, so we just kind of trim these databases a little bit, like remove stuff from them, or we don't import every time we have a kind of soft build, which is not great, because I think you should have a development version as close to production as possible, but it's a way to work around it, to import, say, every week. Maybe things don't change that much, but there should be an option to do it if you want. And then you can auto-blade deployment. That's the principle 8. It reduces development anxiety, deployment anxiety. You know, like all these don't deploy on Friday evening, you know, rules. We don't really have to care about that much, because like we have projects where we deploy almost daily, and it works, and we don't really have this, you know, huge risk. And automatic deployment also empowers developers, because they don't have to have a DevOps person doing the deployment. They can just go in, choose the tag they want to deploy, they build, and it's just going to deploy to production. And we can deploy, you know, 21st, 22nd, 27th, 28th, like whenever we want. You don't have to care. And you know, a developer that works on the project can do a deployment, and it's really tested. And if you have the whole pipeline set up correctly, it's fairly well tested before, so the risks of something going wrong in production are really, really low. And then principle number 9: make it easy to get the latest version. I've got a simple script. It should be easy to set up your development environment quickly. I've seen projects where setting up a local or a development version takes like 5 days, and onboarding a new developer takes 5 days, and then if he leaves the project and then comes back and something changes, and then again 5 days of tweaking, and then everybody has a different setup. There's this, like, you know, you go to the documentation page and you have like 30 steps to set up your development environment. To me, this is crazy. It should be quick. In Droptica, usually you have like 3 lines of scripts, and our kind of official policy to which we are striving is that if you have documentation, these should just be scripts and they should work. Like you just kind of copy them over into your console and just run them, and your copy should be ready. And usually these are like 3 or 4 lines, like git checkout, Ansible build, and that's pretty much 2 scripts usually, or 3, and they just work. And this is great because you can easily test, you can easily onboard, you can easily switch between versions of the same website. You can easily take over from someone or include an expert. So you have a person who's really good at you know, search, or is really good at, you know, JavaScript or whatever. He's not on the project, but you need his help for like a few hours. Onboarding him is easy. He can onboard really quickly. If you have this tedious development environment set up, you're less inclined to include people in the project. Just like for help, and sharing knowledge is not that great. And then how it works in Droptica in more detail. So we have our website, Droptica.com, and we have Robert, our developer here, who really wants to change something on the website. So the way he would do it, we have our source code on Bitbucket, and we have a server with copies of the database, of the production databases, which usually is a nightly snapshot. Right, so we have Jenkins, which automatically pulls the production database every night onto a backup server. Now, the way it is set up is, for each website, we have a sanitization script, so that the database that's copied from production it's already cleared of all the user data, sensitive data. If there are any API keys to, MailChimp or whatever, these are all removed so that you get a version of the website that will not, of the database that will not collect the payment for a credit card in a program from a client, because all the credit card data, if there is any, will be already removed. So the developer doesn't have to worry about that. He has a version of the website without any data. And it has to be automatic, otherwise you're not going to be pulling this database automatically. So he will just run 3 scripts. He will clone the repository, he will copy the database into the file directory, and then he will run the build, and he will have the version of the website ready, and he can start working. And so he just pastes these 3 commands in the console, and he can kind of go get a coffee, and then 5 minutes later, 10 minutes later, his environment is ready, his website is already up and running, and he can start working. So it's really quick, right? So he wants to create a new feature, so he will launch a new feature branch according to GitHub, feature/xx. And then when he's finished, he can already use Jenkins to build a website with his feature present, and can show it to someone, or for example, a tester can manually test it before it's merged to the main branch. He can go in and inspect that, okay, this new banner looks exactly like it was supposed to look, or this new mechanism works exactly as it is supposed to work. He can run all the automated tests on it to check that nothing else got broken in the process of creating this feature. And then he can merge it to development, to the main branch. Usually this happens through a pull request and a code review. It depends on the project a little bit. Sometimes we don't really build each feature separately, but we can if we want. On each project, we can build each feature separately. Then development builds automatically by itself whenever you merge it. And then again, you can do a manual test with a spyglass, you can see. And then we can run all the automated tests, the visualception, the functional tests. Usually the automated tests, which are the functional tests, they run with every build. The visual tests, we usually don't run them every single time because they just take a long time, unfortunately, because it's a pixel by pixel compare and it just lasts a long time, especially if you have multiple pages that you want to compare. But if we want, we can do that. And then once we are happy with the dev branch, we are creating a release branch. Again, we can build it on Jenkins automatically. Then we can run all sorts of tests that we want, like including visual compare, to make sure that everything works. There are no changes, no errors that we are not aware of, and that the build. And this is all automatic, so we don't have to. It's not a lot of manual labor. It's basically a click of one button, and it stands up by itself. And then our clients, they can access these environments, and they can quickly see, okay, this looks great, this looks nice. I am happy for this to go to production, or they can, their own input of, well, I need some more changes, and then we will go through the same process all over again, and we will give them a new website really easily, without too much hassle. So oftentimes we have 5 turnarounds. Like they will say, well, I want this a little bit bigger, and we're just going to build everything again like this. And they're going to be, like this is perfect. Well, and we can do these increments or changes multiple times per day, showing them new versions, and we can release even on the same day. So sometimes when a project moves really quickly, we can release a couple times per day in a controlled fashion without any hassle, any stress or any problems. Right, and when we push to master, Jenkins can do a deployment for us. Now we usually don't have this automated. We usually the deployment is automated, but it doesn't happen by itself, right? Because this stage will build with each commit that is pushed. Usually on master we create a separate release, and then we commit to master, and we actually go to Jenkins and click the release button, and then the whole deployment happens automatically, just the same, and the website is updated. So this is how it works in Droptica. We set every single project like this, and every single project that we maintain goes through this process. Even small projects have this process set up, and it saves us so much time, so much hassle, so much pain that people who join our company and didn't work this way, they work like this for half a year, and they're like, I never want to go back into a different way of working. So we're pretty happy with the way it works. That's why this presentation, because we encourage you to work this way too. And the benefits. So there's one source of truth. So we have a build that shows the state of the project. There is no discussion whether something works or not. You build the project from scratch with a copy of a production database, and this is it. We don't say, oh, it works on stage, it works somewhere there, it worked on my machine. You can build it wherever in Docker, and it should work or not. It's a 0-1-0 discussion. There's an objective way to validate if something works, and this is something from a project management perspective. It's much easier to work with multiple teams because you don't have to do that much communication. Like sometimes you have a Drupal team, then you have a Magento team, then you have a whatever other team, and they all work together, and they're like, and the quality assurance says, oh, this doesn't work, and the Drupal team says, well, it's the Magento API, and the Magento team says, no, the API works, and okay, we're releasing a change, your environment is going to stop working. If you have continuous integration set up correctly, all these problems go away because you can't commit something that breaks your tests, and if something breaks your test, that means your commit broke it and you have to fix it, and it's much, much simpler. It brings a lot of sanity. Also, it helps a lot because in Drupal, many people work in such a way that they click on the database a lot, and they kind of install modules through the UI. If you have 2 teams or 7 people doing it all at once, it really gets messy because one person installs one module, then another installs a different one, then somebody uninstalls a module, and there is no way of then deploying. How are you going to deploy all these changes which are not really kind of scripted anywhere? How are you going to know, like if you stage something for a client and you kind of click all these views to present the new or enable modules to present a new website, how are you going to then be sure that you're replicating it correctly in production? With continuous integration, you don't have this problem. And you can quickly rebuild environments, which I talked about a little bit. You can compare revisions, onboard easy. You don't have to think. So you don't have all these problems. Well, I can't get this thing to work, and I need someone to help me. It just happens automatically, really easy. Reproducing bugs is easy because you have a website which is really identical to production. So if there's a bug in production, you really will have it on your local environment too. And it's also great for projects with intermittent work spikes. So for example, you have a project which is in maintenance mode and nothing happens there for like 3 months, and then suddenly there's a campaign coming up and the client wants something done. Nobody has to remember anything about this project. You can kind of just run 3 scripts, set it up, then you can have a look at it. You don't have to, update a lot of documentation or keep a lot of documentation about setting the environments up available, or you don't spend too much time also on setting up your environment. You can run it up, set it up quickly, do the changes that you're supposed to do, push them. Jenkins will take care of the rest, and tests will take care of the rest. Your QA team doesn't really have to remember what is there to be checked because your automated tests know what they're checking. You can deploy it, and then you can completely remove it from your machine and forget about it for the next 3 months. And this is really helpful. You can test deployments. There are no forgot to switch-ons exactly. So there are no deployments where it worked on staging because these modules were enabled, but we forgot to enable them in production, and that's why it doesn't work. It reduces the deployment anxiety, reduces time drastically, like, deployments take, a few minutes, and don't require a lot of preparations each single time, and developers can do them themselves, so the DevOps team doesn't really have to be that much involved, which can reduce costs as well in a longer period of time. And reliability is improved because even huge changes, like we had projects like if you have a complete website overhaul, right? So you change the theme, add new views, enable modules, change a lot on the website. Deploying, oftentimes people do it in such a way, okay, tell the client not to add any new content for the next month because we're building a new version and now we're going to replace the database after we're finished. Like, some websites can't really do that, right? Some websites have active users who, buy, sell, have data there, log in. You can't really just switch off the database for a month because you want to replace it with your development copy. But you want to do a massive change all at once. And you don't want to shut the website off also for a whole day where you will be kind of trying to move all the changes that you did in your staging manually to production. Continuous integration allows that, and we have successfully done huge overhauls of websites, which were tested over time, and then deployments took 20 minutes, and the website kind of changed completely. And it reduces the amounts of errors and you spot them quickly. And that's that from me. And thank you. And we have 5 minutes for questions if you have any.
Yeah, great speech that. Thanks very much. So there's a question about your pipeline. You didn't talk about creating an artifact anywhere in that process. Is that something you've considered? Or is that something you're not going to do because you believe that your build is so fast that you can regress to a particular tag very, very quickly? Did you capture that? Do I go through that again?
Yeah, please.
Okay, so in your pipeline,
yes.
CI/CD pipeline, you don't create a digital artifact.
So
is that correct?
Yeah.
Okay.
So by artifact, what do you mean?
Okay, so it's going to be a snapshot of your entire release. So it's going to be your contrib modules, the way you build your front end, everything in one tarball.
Oh yeah, okay, yeah, okay.
Yeah, okay. So then we go into production, and you discover that for whatever reason your tag is a bad release. Things aren't going well. How do you regress that then back to a previous tag?
Okay.
You just do a rebuild.
Yeah. Well, I mean, reverting back to the previous tag, we tag our releases, so the code is tagged, and we do backups before each release. That's automatic, the process of the whole backup. So we just roll back to the previous version. But it doesn't happen too often because everything is really well tested. The risk is really low, so we don't really have this too often.
Can I ask another question while I've got the microphone? Sorry about this, guys. So the other question is, you're committing a great deal of work onto the mainline branch, right?
Yeah.
What happens if you then decide, or the customer decides they don't want that functionality right here and now? Do you just rebase it out, or do you cherry pick? What happens?
Depends on the situation. We can cherry pick, we can rebase. We tried many different approaches to branching strategies to avoid the situation you're talking about. We find that every other approach creates some other problems. We then have to either cherry pick, we keep all the branches of all the features in the system anyway, so we can kind of remerge everything back again without the particular feature if we wanted to.
Great. Sorry for hogging the microphone.
Great presentation. I had two kind of specific questions. You mentioned people committing every day on a large project. But you also mentioned code review and pull requests. Is there some sort of warranty that reviewers have to review the code in a certain amount of time before the pull request? So they have to do the review? They have to drop things and do a review?
Well, we usually do this daily, more or less, depending. Like, as a company, we work in Agile and Scrum, so the whole team is kind of, daily meeting, and if there are pull requests waiting too long, they are visible there. So we try to do these as often as possible, but we don't have a measurement of how long they sit there. It's the team's own responsibility to make sure that these happen, regularly, because they get into issues if they don't do it often. So they would usually do it daily.
And my other question was about, we run into the same issue with large databases and getting continuous integration to work in that scenario. Do you have any tips on truncating a Drupal database? Because I don't think it's as easy as just truncating tables.
It's not that easy. No, depending on the website and depending on what the data actually is, you have to make a judgment on what can be deleted. So sometimes we usually delete. A script, and we don't truncate the database as such. I mean, truncating cache tables often and all these saves you some space, but we usually then kind of delete the particular data that is not, like if you have, 1 million blog posts, you don't really have to put them all there. You can delete half of them, and the mechanism of blog will work the same usually. So this is our critical approach.
Yeah, I guess we've just found that even deleting entities is slow. So preparing that database is
yes, it is slow. But we do it then in the backup, development backup. So it happens overnight. We don't really have to do it like on the import, so that when the developer gets the database, it's already small.
Thank you.
Great presentation. Do developers actually run tests locally, or is the entire workflow from I think you said Jenkins? Is the entire testing infrastructure run remotely on Jenkins, and then only at that point would a developer know, oh, my unit tests or my functional tests are failing, I have to go back and fix my code?
They can run them locally as well. Jenkins does it as well.
Okay.
So should they run it locally? Depending on the change, we don't really police that. Depending on, you should make a judgment call. If your changes are massive, or you change a lot of things, it probably makes sense to run this locally to see if you broke stuff. But if you're just playing around with CSS or, one particular feature, you might not need to. Jenkins will do that for you anyway.
Yeah, one thing we found really helpful on my team was most of the tests are run, on our on our Travis build, but we do require there's like a Git hook on your pre-commit. We check code for check code for maintaining code quality standards, and because those run very quickly, we get your early warning, and then everything else will take longer to run on that. So
yeah, we do have we don't check code quality on Jenkins build. We do on some projects. We do have exactly what you're having. We have Git books that check it for us. And we are kind of in the process of rolling out something like it checks Drupal coding standards and all that.
Let's assume that we will need to have different configuration for some modules in development environment or local environment, and since then we are having some differences in config export. How you are dealing with this problem?
Right. Well, in Drupal 8, right, in Drupal 8, you have the config split. You can do that with that. There's a module for that.
Okay.
So
this was curious if there is something more.
But we try to have as few of these as possible. to be honest, because the more the differences we have, the more tricky it is to deploy, because you know that there are changes which might potentially. So, like, also, like, in the build process, which we have, which I showed you here, like, we have like compose file, like, which is a slightly different for development, and then it enables usually Devel modules and or like other modules. Like, we use mail catcher usually to test that the emails are outgoing or correct, so we might, in the build we will change these, credentials and everything, all these settings as well, so that it actually works in a development way. Because that will in the server.
Okay, thank you very much.
The last question, because we're out of time.
Do you use any solution for content deployment, like workspaces module, or do you manage all content only on production environment?
We don't use the workspaces module yet. It is an interesting thing that we didn't look into. We usually do content on production. I mean, that's content, that's how it's supposed to work. If we are supposed to deploy a large amount of content for like a huge rebuild or something, then we would write update hooks which would actually populate the website with content. And then it's easy because, again, you test it on production, like on the database from production, so you're not testing on some other place. And you can easily launch these versions over and over again, checking that everything works correctly without any effort. So we usually write update hooks which kind of create flow. And yeah, that's our approach. I mean, we have this mechanism where we, like, if there's a large deployment of content, we usually create some mechanism that reads from a YAM file, and then you can create a lot of YAM files with content, and they will kind of import all the content from YAM files and update it. This worked pretty well for us in the past. Right. Okay. Thank you very much.